Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the single dial that decides whether your model is a reliable clerk or a wild poet, and why most people turn it without knowing what it does.
Set the stage. The model's about to produce the next word. What's actually on the table at that instant?
At every step, the model hands you a probability distribution over roughly 100,000 tokens. A giant ranked list of here's how likely each next piece is. Sampling is just the rule for picking one out of that list. That's the whole thing. And it's the dial you tune to trade off between predictable and correct on one end and creative and varied on the other.
Start me at the simplest possible rule. What's the floor?
Greedy. You just take whichever token has the highest probability every single time. Say the model's looking at Paris at 62%, the at 18, a few others. Greedy always grabs Paris. It's deterministic, it's fast, and it's gloriously boring. Which is exactly what you want for classification, extraction, structured gesso. Tasks with a right answer.
Okay, now temperature. The famous one. I hear creativity knob tossed around. What's it really doing under the hood?
It rescales the raw scores, the logits, by dividing them by the temperature before the model softmaxes them into probabilities. And the mechanics are worth feeling. Divide by a small temperature, and you amplify the gap between the high and low scores. So the already highest one dominates even harder. Divide by a large one, and you compress that gap. So the scores converge, and the long-shot tokens suddenly get real weight.
So low temperature isn't adding confidence. It's exaggerating a preference the model already had.
Beautifully put, it's sharpening, not inventing. At temperature 0.1, Paris utterly dominates the distribution. Crank it to 2.0, and the whole thing flattens out. Even a weak candidate like A starts winning a real share of the time. 1 is the model's natural distribution. Below 1 is sharper. Above 1 is flatter.
Now here's something I genuinely thought was settled. Temperature 0 means deterministic. Same input, same output every time. That's true, right?
It's the thing everyone assumes, and it's not quite true. Two gremlins break it. First, floating point math on GPUs isn't associative. Adding a plus B plus C can land slightly differently from a plus B plus C depending on how the work got batched. Second, exact ties in the scores get broken arbitrarily. So a frontier model at temperature 0 is mostly reproducible, but not bit for bit identical across runs.
So if I truly need determinism,
You also pass a seed. Some providers support it. And even then, you expect the occasional drift. Temperature 0 buys you stable, not sacred.
alright, there are two more. Top K and Toppy. Give me Top K first.
Top K chops the list down to the K highest probability tokens and zeroes out everything else before you sample. It's there to cut off the long tail of unlikely garbage. The weird, near zero tokens that occasionally sneak through and derail a sentence. Typical K is 40 or 50. Simple and effective.
And Toppy. You flag this as the one to really understand. Why?
Because it adapts. And that's the magic. Toppy sorts the tokens by probability and keeps only the smallest set whose cumulative probability crosses your threshold, usually 9/10. People call that surviving set the nucleus. So you're not keeping a fixed count, you're keeping just enough tokens to cover 90% of the probability mass.
Let me try to land why adapts is the whole point. When the model's sure the capital of France is, the nucleus is what, 1 or 2 tokens, and when it's wide open. Once upon a time, it balloons out to 50?
You just nailed exactly why it beats Top K. Top K forces the same K, no matter how peaked or how flat the distribution is. 5 candidates whether there's one obvious answer or 50 plausible ones. Toppy reads the shape and resizes itself. Tiny when the model's confident, wide when it's brainstorming. It follows the model's own certainty.
There's a trap I can smell coming. People must crank temperature and Toppy at the same time.
And that's the mistake to avoid. They both reshape the same distribution, So tuning both at once makes the combined effect impossible to reason about. Pick one. Most production setups pin toppy at 1.0 and tune temperature, or pin temperature at 1 and tune toppy. Move one lever, hold the other still.
Give me the cheat sheet version. What do I actually reach for?
Classification, extraction, JSO, temperature 0, code generation, around 0.2. Document Q&A, your typical RAG, 0.1 to 0.3. Conversational chat, about 0.7. Creative writing, push it up near 1. And these are defaults to override only when you have a reason, not commandments.
One last gotcha, because this one feels like it quietly ruins experiments. If I'm a 2B testing two prompts at temperature 0.7,
Run each one multiple times, or you'll fool yourself. A single sample at 0.7 is noisy. Prompt B can look better just because it got lucky on one roll. Average over at least 5 to 10 samples each, or run a real eval. Otherwise, you're reading the dice, not the prompt.
so the one sentence?
Sampling doesn't pick your tokens. It reshapes the distribution you draw them from. Greedy for facts, a measured temperature for everything else, and tune one knob at a time.
Sharpen for correct, flatten for creative. That's the Datarekha audio guide. See you in the next one.